Hello. Hi, everyone. Thank you for having me here. I'm happy to be representing BCG, it's Boston Consulting Group. I am an associate director out of our New York office. If you're not familiar with BCG, we're a global consulting firm with about 29, 30,000 people around the world. We've got an office here in Dubai. And within those 30,000 consultants, we actually have a sizable tech group, about 2,500 engineers and technologists. And I'm part of our advanced analytics group. I actually am here with my product team. Half of my product team is sitting up here in the front. We look forward to speaking to any of you at the lunch break if you have further questions. One of the key areas that BCG works in is in financial services. And over the past several years, we've built out advanced analytics applications for the commercial banking sector. And the development of our advanced analytics models, core predictive models for commercial banking around risk or around product selection, around credit authorization, have been developed in very much like an analytics data science sort of way, kind of an engineering black box, trained model, trained by data scientists, where we then pass in on a regular basis a company's data to make decisions on credit worthiness, credit scoring, attrition risk, commercial product mix for financial services. And what we'd realized is that actually to enable our clients to be able to leverage those analytics capabilities more effectively, beyond it just being a smart data science model, it's really need to be built into their business and built into their business process. And while we're here at PyCon MEA, those models are all built in Python. So in BCG, we're very heavily a Python shop. My background is 20 years of Python software development, mostly in the computational science space and high-performance computing space. But what we realized was that when you're working with bankers, working with businesses, giving them a Python data science model, that's just the start of the story. And so what we've developed over the past year is actually a Python-centric SaaS offering called Smart Banking. And our Smart Banking platform, we then license to our clients, and it acts as a hosting framework for those analytics models, for those advanced analytics models. So this is all background. We're still just looking at my first title slide here. But I want to set the scene for what it is that we're discussing. So you're here at the Global DevSlam event, the PyCon MEA. What's the main story that I want to communicate to you today? One, that the Python ecosystem, as we've heard from several of the speakers here, and of course it's kind of like your speakers are a biased audience in this space, but one, that Python is a great foundation for robust enterprise-oriented applications. And so we've been building basically a whole core of our Smart Banking full SaaS application also in Python. So our data science models are in Python, but actually the whole framework around that is in Python. This talk's really going to be a very broad talk around all of those Python components. And in 20, 25 minutes, I'm only going to be able to touch on each of those topics. Not go into any great depth, but one is that it's a great foundation. Second of all, for people out there who are, I hope many of you are already Python programmers, maybe even professional Python engineers, to get a bit of a sense and maybe a bit of a playbook for what are some of the components that you can tie into that go beyond just writing Python scripts, or if you're a data scientist, Jupyter Notebooks, or building out a library component that then's leveraged by someone else. We had our opening talk, lots of those open source developers building some amazing Python libraries. I use a number of them. I now want to use even more of those. But that you can really go beyond that to build a full end-to-end solution. And so as an engineer, and again, as I said, I hope many of you are engineers, you're able to get a sense of how much of that Python ecosystem you can leverage to build that complete ecosystem for a full product solution. So what I'm going to be demonstrating today, we've got a team of about 10 people that over the course of 9 months, so you put the numbers together and you're looking at 6, 7 person years, have built an enterprise-ready commercial banking platform for hosting and managing advanced analytics. This is my background. I'm going to take the next now that I've gotten through my introduction. I'm going to take the next 15 to 20 minutes to show you some of those pieces. how they fit together, and then leave hopefully a lot of time for questions. You got questions in that space of building an enterprise application, building a SaaS service, working in the financial services space. I'd be happy to answer. I'm going to actually have my tech lead for the project, who's also here with me. He'll come up to help with some of the Q&A. So we'll get into those details. Oh yeah, so hopefully I've been having this problem with PowerPoint, and look, PowerPoint's. Just give me a second here to. Hopefully, I'm used to, during demos, having my software stop working, but PowerPoint not working is less fun. Hopefully we'll get PowerPoint back up here. All right. Great. I'll try and talk more quickly before it crashes again. Okay. There we are. Okay, I've kind of given you some of this background information already. I've already given you some of this background information on the smart banking application. The target, again, as I mentioned, the target is to really enable banks to be able to do some interesting work with the data that they have available to them. That today, in a lot of contexts, bankers will be going off of experience, intuition, but the data streams that are available to them provide much more interesting opportunities, and that's really the motivation behind our smart banking AI application. It's this concept of taking data, being able to aggregate data into interesting ways, proprietary data sources, external data sources. The signal, we can use the signal around a number of different models. So that second box shows the half dozen to a dozen different specific data science models that we've built. We then license those to our clients. They can take one, two, they can take the whole lot. From those data science models, we then generate insights that are then actionable insights that can integrate into the banking processes, to the client management, to the account relationship management, and then that then drives actual action within the organization. So that's the business part of the background. From here in, I'm hopefully mostly going to be focusing on the tech components. And again, as I mentioned earlier, the main focus is that this application that we've developed, the whole heart of it is in Python. There are Django developers here. Anybody who's built anything in Django? I hope there's at least a few of you. A couple hands coming up. So the Django framework's been around for maybe not quite 15 years now, but getting pretty close to it. Maybe it is even 15 years when I think about it. Today, it continues to be an extremely robust framework for building enterprise scale applications. So we use it in many places in BCG. We'll use Django as a core to allow us to build out a lot of the back end. 15 years ago, I was building applications where even the front end was leveraging the Python Django components. Today, the right end of the picture is the right end of this slide is a more appropriate space really to building an enterprise-oriented application. You want your user experience to really be centered probably in the popular JavaScript frameworks of the day are really in the React TypeScript space. We're using Material UI and high charts. I'm not going to talk about those parts too much, but just to highlight that we have those parts, the front-end components are done in TypeScript for React. Our V1 instance of our smart banking application was actually developed even on the back end all in Node. We found it gave us a lot of challenges around full end-to-end enterprise application development, around testing, scalability, modularity, our database interactions, and persistency layers. And for that reason, our V2 application, which we only started developing in January, we started from scratch and we rebuilt the core. In Python. And in that space, leveraging the Django REST framework, incredible mechanism to be able to expose the APIs. We saw in our first talk, Fast API as a mechanism for exposing it, and some of this people that were mentioned were actually developers of the Django REST framework. We use the Django REST framework for providing a secure, authenticated, well-defined RESTful API. the Apache Airflow environment for our data flows, frictionless framework for our data validation, the modules around that. And then the bottom rows, again, I'm not going to talk about the data science elements too much. This is more around the application framework and not the modular data science components that we're building. This is just touching on a few of the pieces. In fact, we find even with about 1,000 data scientists in Gamma, we do a ton of our data science work leveraging like some of the simple tools, XGBoost, Pandas, some scikit-learn. You get a long way with just some, a little bit more than basic decision trees, but still, those are our core data science libraries. And then on the left side, some of the pieces I'll talk about also on our polar policy language. It's not strictly Python, but it has some Python libraries that'll leverage that. And then Terraform is our infrastructure as code. What this is trying to capture here in this one slide is if you were to go and look in our code repositories, what's the code that we're committing? The code that we're committing is about a 10 to 12 person development team. It's all in this space. So all of the software we're developing is all represented in the slide. The majority of it is in that core space, all in the Python ecosystem. This is our architecture diagram. So if you want to build your own smart banking application, if you take a picture of that and you can go and try and build that system. I think one of the things that we appreciate is that we're happy to share this kind of detail of what we're trying to build. That, as everyone I think here knows, experienced engineers at least definitely know it, the devil's in the details, and then it takes a lot more than just building the piece of software to actually deliver it successfully to our clients. So we're going to touch on maybe about half of the elements that are represented in this slide. The green parts are basically the parts that BCG's colors are green, and so you'll see a lot of green in BCG slides. The green parts are the core software that we've built. The blue parts are the pieces that we interface and interact with that are external to the core application. And another piece that I'm going to mention here is that when I was building scientific applications 10 years ago, you'd have to build pretty much the whole thing yourself. You might get some open source components and have them part of the server that you were running, but it was kind of like the whole system would be running on your server or your network of servers. Today, there's so many external services that you link in. The selection of those services and how you effectively leverage those services is a key part of building an effective application today. And so again, this is a little bit of like a message for people who are maybe very heavily in the Python space or think a lot more about how do I build myself from the ground up my own environment. We heard earlier Sebastian, I think, was talking about building on the shoulders of giants. Well, really the Python ecosystem is all about building on the shoulders of giants, and today, that means going beyond even just libraries to really effectively leveraging those external services that you integrate with for notification systems here, for logging and monitoring engines. Datadog, we leverage Datadog very heavily. 10 years ago when I built these things, I'd be incorporating in my own logging and log management and monitoring and alerting systems, softwares, and servers, and be like 100% running on the machines that I put in place. Now that's all like an external service, and we just route and pipe things to those external services. That's probably all I'm going to say about the external parts. I want to spend more time on the internals. So I'm going to give you a quick view of what does this application we built look like, just so you get a sense of like what is this actual thing we've developed, and then move from there to a little bit more of like the components that make it up. But this hopefully will put us in a place where you can actually see the application. Let me just I've lost my authentication here, so I might be limited in what I'm able to show you here without my network connection up and running. Yeah, I might be able to only show you some of the. I've got screenshots at a later point, but that's a little bit disappointing. I've got my I'd preloaded them, but I think with that network failure, I've lost the demo element that I can bring up. I might come back to that later when we're in Q&A. I'll see if Santiago can answer some questions, and I'll get the demo element up, because what I have here is a little bit different. So, okay, so we'll have to skip that part for now, and I'll come back to showing that element afterwards. So I mentioned is the team that we've got. About half the people, and especially most of the people in the top right, are here in the room today. So be happy to talk to you more at lunch. I'll talk you through some of the components that make up this application. So today, I'd say in the Python ecosystem, the two most popular workflow management frameworks are Airflow and Prefect. Airflow is the incumbent, Prefect is the challenger. We actually built our V1 system on Prefect version 1. At that stage, Prefect looked really promising. It is really promising. It's a great workflow management system. Airflow 1 had a number of shortcomings that meant that we were really happy to use Prefect. Well, in the course of using Prefect through 2020 and 2021 for our application, Prefect had a lot of, let's say, growing pains, effectively. And we found ourselves, as we were planning for our V2 development in late 2021, Prefect 2 wasn't out yet. It was in a beta. It wasn't clear when that beta was going to end. And Airflow 2 had just come out. And at that point, we were like, look, we've got more engineering talent, which is experienced with Airflow. Airflow 2 is robust. We'd love to stay with Prefect and use Prefect 2, but we can't wait around for the full release versions. That's like kind of a true story for us and why we moved back to Airflow. So I think Airflow is a great framework for workflow management. So we use Airflow for our EVL, extract, validate, load steps, where we go from client data, which we get from SFTP synchronization, to Parquet files on disk. We then do the necessary transformations, feature engineering steps, and then an ETL step. So we've split those two parts. We've got workflow, automated Airflow workflows for orchestrating and managing those components. One of the interesting things that I've observed is I feel like there was a point in time where people were kind of like all in the database space or all in the file space. What we've ended up developing, and I think this is happening in a lot of other environments as well, is that you end up with a hybrid environment where some of your data ends up being files on disk. The volume of the data, the format of the data, the way that it's going to be consumed and processed, doesn't make sense to load it into a database. It might have been in a database once upon a time, but in data science applications, you do kind of like bulk processing of that data. Parquet gives you a little bit of the best of both worlds, that you can do a degree of rapid parallel processing and parallel load of the data, but you don't need that data sitting in a database. You're not doing like row-level selections. You're kind of like bulk processing it. In that context, Parquet and file format is really the most efficient for fast loading, efficient storage, and so on. But then there are other elements where you really do need a persistency layer, and so that's one of the great things about Django, because of it being really like a full-featured application development framework. It gives you the ORM layer, the object relational mapper, so you get Python classes that are persisted in database tables, which then give you the ability to write very vanilla-looking Python code for your application development, while the things you're working on in code can be actually in a running application persisted to a database rather than just like in memory temporarily. So we have that blended kind of environment where some of the process through here is actually going to result in objects in our database, and others going to result on files on disk. We just got to manage that interplay pretty carefully. Our server-side data processing, it's entirely in Django. I was just mentioning this persistency layer. Using the Django ORM, and then the RESTful APIs, so that on the client side, client's getting those results back. The client's getting those results back through the Django REST framework, so JSON. I mean, we saw the slide earlier, JSON everywhere. It's like it's JSON all the way down. Well, it's JSON all the way down in terms of our RESTful interfaces for our application. So I'm going to take a moment to mention this, but if people have more questions about this, as I've mentioned, my colleague and our application tech lead, Santiago, will join me for Q&A in a couple minutes. The Polar policy, the OSO project and the Polar policy language for role-based access control is extremely powerful and very valuable for any enterprise-oriented application, where we really need to have fine-grained differentiation between what can different users do within an environment, not just like what parts of a website can they see and what buttons can they click, but also to the level of like row-level access. So we're dealing with an environment where we've got bankers. The bankers have access to some client data, but not all client data, some account data, but not all account data. And this gives us the ability to really structure and represent our bank's organizational structure very well, very effectively. every bank has their own different policies about who can do what and who can see what. We can then represent those in a policy language. We can then create that policy, review it with the client, and then assign roles to individuals either from the identity management system that we link into, or by custom setup and configuration. And this has been a real enabler for the usability that we need, not just to have like the demo of like a single banker in a demo environment where you're really thinking about the organizational aspects. MLOps, so the MLOps workflow is an important element of how do we actually think about these models? As I mentioned, we've got about a half a dozen to a dozen different data science models. Those data science models have to have a level of review and validation. They're parameterized in terms of their behavior. So not only are they trained about once a year, we do a retraining cycle about once a year in a commercial banking setting. The model's behavior is relatively stable. Also, having information about client behavior in a commercial banking setting doesn't change on a day-to-day basis. It changes more like on a quarter-to-quarter basis, which makes about an annual retraining cycle appropriate. Having an MLOps framework in place is really important. I'd say it's really improving on this, and I'll come back to this in a few minutes, is really one of our 2023 goals to make our MLOps framework even better. MLOps, there's some great Python-based frameworks in place. We're doing something a little bit ad hoc in our current V2 implementation right now, but managing those data science models within the Airflow workflows, the parameterization, the model versioning, the provenance tracking of what model is being run at what time, with what parameters, against what data set to produce what results. Very important in a banking context where you could be audited, where you need to be able to justify why you've made particular decisions, and so on. The Django admin UI, I think, is one of the great enablers of using Django. You basically get a whole admin interface for free, so that rather than having to do, as engineers, we'd be like, oh yeah, we can just like change that configuration. Well, going in and making modifications on the command line and committing them to your repository, or just changing them in place and like restarting your server, this is a terrible option for a bank's operations team, or an environment where we have a SaaS offering that we're hosting on behalf of the bank. We don't want to have to get a phone call saying, hey, please could you change this like threshold from $12,000 to $15,000 or something like that, right? So the Django admin UI gives us the ability to expose to authorized users at a bank. They're able to get in here, they're able to make adjustments, they're able to view and do fixes where you're just like, oh, you know what, like the application doesn't allow these kinds of changes directly, even for a manager, but an authorized administrator can go in and can tweak the data, and nobody needs to get like a SQL shell to go and modify the database, right? It's the kind of thing that are patterns you want to avoid, and the Django admin UI really gives us that ability. I mentioned the RESTful API already. I'm going to skip over that. Testing framework, our CI/CD is all in Circle CI, and then we use Cypress for our front end and PyTest for our back end testing, and our lead QA engineer is also here with us today for more on that, and this is just a screenshot from the Circle CI. If you're not doing some kind of CI/CD today, then I definitely would say invest time in that. I mean, test-driven development, and then a level of hooks into your repository for your code to be validating and getting continuous feedback on metrics, on code coverage and code performance, critical for a robust application. Okay, and with this, as I said, I've touched on a number of the elements that make the smart banking application a reality. Hopefully, a little bit of a roadmap for how you can build a robust SaaS offering anchored in a Python framework. I've got here just 5 lessons learned, 5 just because of the time constraints, and I wanted to fit it all on one slide. 1, Django is an amazing framework for building a SaaS application. 2, Airflow 2 is a great workflow management environment. And again, I'm not trying to say Prefect 2 isn't good. Now Prefect 2 is out. I would definitely consider both of them, but if you're not familiar with workflow management engines in the Python ecosystem, you definitely should make yourself familiar with one or both of those, because really for serious application work, these are mandatory. We in BCG, we use these in practically every client engagement that we've got. We're using one of Prefect or Airflow 3 also, and the Polar policy language for role-based access control and policy creation. This is so much better than any kind of ad hoc implementation of policies that get embedded in code. In terms of reasoning, configuration, security, absolutely essential for any really robust multi-role kind of application that can link in with your employers or your clients or customers' environment. 4, MLOps is important and hard, and as I mentioned, this will be a priority for us in 2023. And finally, containerization, CI/CD, and infrastructure as code. These are all essential. One of the things we learned from our V1 system is that people can go overboard on this and tightly couple the infrastructure as code and the containerization to the actual development environment. It slowed us down dramatically in our V1 development of our smart banking application. In our V2 environment, what became a priority for me as I laid out tech direction was to ensure that developers could be building components without any containerization. Containerization was an optional later layer of the development process, not a necessary embedded layer. Those are my core lessons from this. Again, I want to say thank you to my team, most of whom are here today, who have helped make this possible over the last 9 months. And here I've got a QR code which will take you to the BCG Smart Banking webpage around what we're doing in smart banking space. And you can reach me on Twitter, you can cyberstalk me, or talk to me over lunch. And I think I've got hopefully a couple minutes for questions still. Hopefully I left enough time.
Thank you, Ian, for that amazing talk. Really, really insightful there.
Santiago, do you want to come up and join me?
Yes,
feel
free.
Thank you.
Do we have any questions? Right there, let's start.
I'd like to ask where we can find training for us to build such application like yours. Before I tried to build attendance system using the Django, but I remember one of the first things I faced, how to make reporting system is the same like, for example, Crystal report, which is using in .NET. How we can make reports, I couldn't solve this problem. So where we can find the training to reach this level?
So my first answer would be, you've probably already gone through the Django tutorial. The Django tutorial is excellent, and doing that end to end is probably now, it used to be a 1-day commitment. It's probably now a 2-day commitment to do I think it's a 6-part Django tutorial. We actually have for our smart banking team, when new engineers join us, they've got a boot camp that they go through. We actually, I think on my last slide, we had our, it's not up anymore, that's fine. We had a list of our boot campers. I would start with that if you haven't done that already. Beyond that, the details of what it would take to be building out the reporting system, that's not going to be a Django-specific thing. I think that's going to be a matter of establishing how you're going to do, probably translating the content that you've got in your ORM to what do you want the report representation to look like. And then it's going to be a question of working with some good web developers and web designers who can give you something that'll look good on the screen, that will translate really nicely to print to PDF if what is important to you is report export. But that's the best advice I could provide. Stack Overflow, we had some mentions earlier of Stack Overflow. I'd ask on Stack Overflow, describe what you're trying to do, tag it with Django and Python, and there's a really helpful community out there. I mean, one of the great things about the Python community is how much people want to help others.
Thank you.
Okay. Any other questions? Yep, right there.
Hi, Stefan speaking. In terms of scalability of backend services, do you use Kubernetes, and which cloud provider you use? Thank you.
Hi. Okay. So for scalability, we are both planning on being able to use Kubernetes, but for the moment, we also have our demo systems are also using Docker Compose and other utilities that don't need that level of administration overhead. So we are thinking on both depending on the scale of what we are aiming to. But yeah, definitely Kubernetes is there in the picture, and that's the way that we are deploying our V1 system as well, and that's how it's going to be.
Yeah, we've got a blue-green deployment right now. Our clients are predominantly in the US. We've got like an East Coast and a West Coast deployment. They're both hot. but we can then swing between blue-green to scale and then ramp up our Kubernetes pods. Our scalability, we're fortunate because in a commercial banking setting, our application doesn't serve the bank's clients, it serves the bank's employees. It serves bankers themselves. And so in that context, our peak load for our clients would be if all their bankers were using it at once, a couple thousand people, and they're never using it all at once. And so we don't have quite the same scalability issues, but between what Santiago was saying, yes, it's Kubernetes based. So.
Actually, one of our scalability issues is more on the other side. Is making sure that the systems are warm for the kinds of queries that the bankers want to do without having to load them uncached.
Thank you. Any more questions? Right there.
Thank you. Generally, when you're dealing with financial data, sometimes there's a bit of tension between user requirements. Users want fast access to data and ease of not just querying, but their transactions, they want them to be quick. And you want them to be secure, and you want to ensure that integrity. How do you guys handle that?
Yeah, so great question. I want us to have a system. Today, our smart banking environment, as I mentioned, is designed predominantly for commercial banking and to serve bankers directly. The next wave of our development, maybe a future V2, but maybe possibly not until a V3 instance, will be designed to be able to support real-time or near real-time and pass-through capabilities that could be leveraged by public accessible services. And I say public, it'd probably be account holders at banks. That is absolutely achievable in the Python ecosystem. It's more a matter of how we prioritize the design of that. All of us here, I'm sure, have our bank's applications running on our phones. So banks do it today. So it's definitely possible, and it's then just a matter of, do you have the right processes in place around robustness and security and information protection. A lot of those are around policy design, and the issues that once upon a time were around performance. Performance issues aren't really the problem anymore. They're architectural solutions to the performance issues. The challenges are more around security and robustness, and those require more careful thinking. That's one of the reasons why I'm so excited about OSSO and this polar policy language for the capabilities that it gives you. We saw in the first talk the examples of how you can do type annotations to help with type checking. Well, if you extend that concept to what OSSO and the polar language, policy language give you, it gives you that kind of concept about what can Santiago see when he accesses the database versus what can Ian see. You can assert that in the policy language, and then as long as you validate your policy engine and you can review and confirm your policy definitions are correct, and those are hard things to do. Getting the policy definition correct is hard to do, but if you keep it as simple as possible and you can verify that, then those are where the bigger challenges are, really. So.
Very excellent. One more question in the front. No, right in the front here. There.
All right, that is a great segue for my question. So, policy and authorization in general is pretty wild, wild west today, right? Have you considered other things like OPA or Keto from the Ori stack and things like this? Or if not, what are the strengths of also, especially around policy testing and things like this?
Okay, so that's a very good question. Regarding other alternatives, we were looking to what met our specifications for this, and we found out that with Polar, the foundation of it is a logic language, and that is part of the great strength of it, because with any declarative programming, it's just like we had on 2 talks ago regarding big O notation. We don't have to specify how things are done, only what we want, the properties that we want them to achieve. And that's a way to best reason about these kind of things, which is access control in the end. We don't care how much, what's the path that the data is going to take, only whether it's allowed or not. And that's kind of the foundation of this. The also building block allows us to get from that policy language files and reify them in a way that we can query which are the policies that are available. And from there, we can see what users can have access to. Not only query whether they have access to a thing, but also to allow which are the roles and the permissions that that user has, like on a broader sense. And that is great for audit logs and for making sure that things work well in an enterprise-grade application. Not sure if I answered fully your question. Thanks.
Great. Any more questions?
We can take questions over lunch. I know we're 6 minutes into people's lunch break. We're going to be around here, myself and the rest of the product team who's down here in the front. So thank you, everyone. Thank you very much.
Thank you, Ian and team.